jawapan itu, babe. Tengah buat apa?
I tengah study ni kat dalam library. Alamak. Hello.
Hello, babe. I dah tunggu you 8 jam dah ni. Kenapa you tak sampai-sampai lagi? Daripada tadi, on the way. Dah dekat. Tapi tak sampai pun. Cepat sikit. Bye.
Yeah. I on the way ni. Sekejap lagi I sampai lah. Okay. Sikit lagi. Okay, bye. Hello guys. The question asked in the video just now is an example of negative binomial distribution. In the connection with repeated Bernoulli trials, we are sometimes interested in the number of trials on which the R success occurs. For instance, we may be interested in the probability that the fifth person to hear a rumor will be the first one to believe it, or the probability that a student will fail for the second time on his or her 8th examination. A negative binomial random variable is the number of X repeated trials to produce R successes in a negative binomial experiment. The probability distribution of a negative binomial random variable is called a negative binomial distribution, which is also known as the Pascal distribution. If we want our R success to occur on the X trial, we know that our sequence of outcomes must take the form observation 1, observation 2, observation X minus 1, and the final observation, which is the success, in which the sequence of observations observation 1 until observation X minus 1 contains R minus 1 successes and X minus R failures. We do not really care how R minus 1 successes are scattered in the X minus 1 trials. What really matters is the number of ways to do the scattering. So the number of ways of choosing R minus 1 positions for the successes from X minus 1 spots. So the probability of a sequence of length X which contains R successes and X minor R failures is putting this together, we find the probability of obtaining the R successes on the X trial is given by So I'm going to show you again the Sulaiman's question just now. Based on the situation just now, there are 7 repeated trials. Each trial can result in just 2 possible outcomes. We call one of these outcomes a success, which in this case, when he tells a lie. Success. Lie. I wish. And the other a failure when he doesn't lie. So from there we know that success is not necessarily a positive thing. It doesn't really matter. To answer the question, we know that the value of X is 7. That means there are 7 repeated trials. The number of successes, which is 3. That means he lied for 3 times. And the probability of success is 0.7. So when you substitute it into the equation, you will get So what does that mean? It means that there is about 4.167% of chance that Sulaiman lied for the third time in their 7th conversation.
Okay, we know that a negative binomial p x equals to x, and here we must observe all our success. Let's say p x minus 1 r minus 1 p r minus 1 1 minus p x minus 1 minus r minus 1. Okay, and we get negative x minus 1 r minus 1 p r 1 minus p x minus for x p r plus 1 r plus 2 and so on. Okay, then we have p x is equals to x is equal to 0 for x less than r. Now let's look into the expected value, where e summation of x equals to 1 r y is equals to x. Okay, and we have to wait for the first success, and then another second success, and then third success, and then where is, okay, here we have yx, where yx are independent geometry series. Okay, so we have summation of x equals to 1 r e y x. Now when we summing up all, so we get 1 over p, which is r over. So this is our expected value for negative binomial random variables. Thank you.